Walk into any biology lab, anywhere in the world, and you'll see this. Bottles on shelves. Lots and lots of bottles of clear liquid. These are all stock solutions. Now, stock solutions are used to make more complex solutions that can be used on a daily basis in experiments. But in order to be able to make those solutions, you need to be able to calculate dilutions. Now, every year I have students come into my teaching labs, and they all seem to have this formula memorized. It looks simple, and it is simple. But every year I see so many of them struggle to get the right numbers out of this formula. So, in this video, I'd like to go over 3 of the most common mistakes that I see. And by the end of this video, you will be able to use this formula properly. Problem number 1. Let's call this C watt, V watt. This is where some students have trouble applying the right C or V to the right part of the problem. So let's take a look at this problem that's presented here and break it down. We are being asked to make 100 milliliters of 0.2 molar tris solution from a 1 molar stock. In many cases, what I see is students aren't sure if this is this C or if it's this C, and if this V is this one, or what's going on. So, in order to understand this, let's take a closer look at what this word problem actually means. So, what we have here is a story about a bottle of 1 molar tris. This is your stock bottle. Now, you will be using this to prepare a new solution in a beaker. You will be making a 0.2 molar tris solution. So here's our label. And this solution will have a total volume of 100 milliliters. So the question is, how much of this do you take and transfer into the beaker? I think what might be helpful is to turn these numbers that you see here into something that might be a little bit more useful. The way that I learned this formula initially was CI/BI, where I is equal to initial and F is equal to final. And so if we apply this formula, it might be more helpful. Let's take a look. If we look at this situation here, this right here is what you want to make. This will be the final solution. And so here, the VF will be equal to 100 milliliters, while the CF, the final concentration, is right here, is 0.2 molar. Now, what you have in your stock solution is the initial situation. This is what you start with. This is the initial solution. And all that we know about this is the concentration. So this is our only known about this, and that's the CI, which is equal to 1 molar. What we want to know is this part right here. How much of this solution are we transferring? Which is our initial volume, which is what we're going to try to solve for. Okay, so let's try to use that to take a look at a few problems. So here is one sample problem, and so let's just color these guys in. So I'm going to say that CI is going to be blue, CF is going to be green, and I'm going to use yellow for VF, and I'm going to highlight my VIs in red. And so if we look at this first problem, how much 0.5 molar EDTA stock would you need to make 20 milliliters of 0.01 molar EDTA solution? Okay, so if we look at this, we try to break it down in terms of what we're starting off with and what we're ending up with. The stock solution is our initial situation. And so what we have from the initial solution is the concentration. So 0.5 molar of EDTA stock is our initial concentration. The final concentration that we're trying to make is over here, 0.1 molar. And the final volume is 20 milliliters. So if we now try to plug the numbers in, then we're going to start with CI VI is equal to CF VF. Then our initial concentration is 0.5 molar. Our VI is what we're trying to solve for because we don't have that information given to us. And the remaining numbers are coming in from here. So the final concentration is 0.01 molar. And the final volume is 20 milliliters. So if we solve for VI, then we get 0.01 molar times 20 milliliters divided by 0.5 molar. The concentration units will cancel out, and that will give us 0.4 milliliters. Let's look at the next problem. So here we start off with a 1 molar phosphate buffer, and we use it to make 100 milliliters of 0.1 molar phosphate. So again here, the CI, our initial concentration, is 1 molar phosphate. Okay, so that's our stock. Our CF, our final concentration, is 0.1 molar phosphate. And our final amount that we want to make, our final volume, is 100 mils. So again, our CI is up here. Our VI is what we don't know. We want to solve for that. So how much of the initial phosphate buffer we need to use, we don't know. Our final concentration is CF, is the 0.1 molar. And our VF, our final volume, is 100. So let's plug these guys in. So 1 molar times VI is equal to 0.1 molar times 100 milliliters. Always include the units. So VI is equal to 0.1 molar times 100 milliliters divided by 1 molar. Again, the units here will cancel out, and you will get VI equaling to 10 milliliters. So that means that you need to use 10 milliliters of 1 molar phosphate in order to make a buffer that will be 0.1 molar once you dilute it up to 100 milliliters. Let's take a look at this last problem here, because this one's a little bit different. So in this case here, you are told that you diluted 5 milliliters of 0.5 molar NaCl solution to make a new NaCl solution with a total volume of 50 milliliters. And it's asking you, what is the new concentration? Okay, so in this case, they have given you, or I guess in this case, I have given you 0.5 molar as your initial concentration. So this is your CI, that's your stock solution. I have also in this case given you your initial starting volume. So you took 5 milliliters from the stock solution and you transferred it into a beaker. So we have the initial volume, and you've also been given the final volume, which is 50 milliliters. So in this case here, the information that we're missing is the final concentration. So again, let's just write this out. CI VI is equal to CF VF. So CI in this case here is 0.5 molar. VI is 5 milliliters, because we have that information. CF, we do not know. That's what we're trying to find out. And VF, the final volume, is here, 50 milliliters. So you made 50 milliliters in total. That's your final volume. You started out with 5 milliliters, so that was your initial volume. And so you're trying to now find out what is the final concentration. Okay, so let's plug these numbers in. So we're going to go with 0.5 molar times 5 milliliters is equal to CF, which we do not know, times 50 milliliters. So just we're going to solve for CF this time. I'm just going to leave these numbers on this side, 0.5 molar times 5 milliliters, and divide that by 50 milliliters is equal to CF. So in this case here, the milliliters will cancel out, and so I will have a final concentration in moles per liter, or molar. And so in this case here, our concentration is 0.05 molar, so CF. Okay, so that means that the final concentration that you prepared using this procedure was 0.05 molar. Okay, so this is how you assign the values to the different parts of this formula. Again, I feel like using CI/VI equals CF/VF is a little bit easier or a little bit more intuitive than C1V1 equals C2V2. You could also call it CS/VS equals CF/VF. So S for starting and F for final. As long as you try to understand what it is that the problem is telling you about the starting conditions and the final conditions that you are making. The second common problem, let's call it plug and play. And here the most common problem is that what students will do is they will just take the numbers that they see in the problem, simply plug them into the formula without looking too closely at what is actually in there. Let's take a look at this problem here. So here you're asked to make 100 milliliters of a 200 millimolar solution of tris from a 1 molar stock. Now this problem doesn't seem to look very much different from the original one. In fact, it isn't. The only difference here is the way in which I wrote out the final concentration. So this number over here is a little bit different than the one that I used in the initial version of this. And so what you'll notice is that the concentration of the stock solution is given to you in molar, moles per liter, whereas the final concentration, so the CF, is given to you in millimoles per liter, or millimolar. These two units do not agree with one another. They're not interchangeable. And so you cannot just directly use them in the calculation. What you have to do is convert one or the other into the same format. Now, the nice thing is that molarity is just like any other SI unit, so we can just use the same rules as you would for any other SI unit to convert between them. Here we will take 200 millimolar and convert them into moles per liter. So you can see here we're converting into towards the left. And so what we're going to do is we are going to shift the decimal point, that's the end of this 200, 3 places to the left. And so what we will get is 0.2 moles per liter, or 0.2 molar is the correct converted number. Now that you have this, you can plug that directly into the formula and get the right answer. So in this case here, we're going to call this 0.2 molar. And so now CI VI. So now CI is equal to 1 molar. We don't know the VI, that's what we'll be solving for. CF is equal to 0.2 molar, so the units are the same. And VF is going to be 100 milliliters. So we'll plug these numbers in. So we get 1 molar times VI is equal to 0.2 molar times 100 milliliters. So VI is equal to 0.2 molar times 100 divided by 1 molar. So again, here the concentration units will cancel out and you end up with milliliters as the units of your answer. So VI is equal to 20 milliliters. Again, the key here is converting the units so that they are the same on both sides of the equation. We'll call the third most common problem dealing with complexity, or maybe rather not dealing with complexity. So what do I mean by that? Well, in many cases, when you're looking at one of these dilution problems, we are quite often dealing with making a more complex solution from our stock solutions. That is a very common thing that we have to do in the labs, and so quite often the problems you see on tests and quizzes tend to take the same format. And so you'll be asked to do things like this, where you are asked to make a 100 milliliter solution of 200 millimolar tris, 10 millimolar KCl, and 5 millimolar magnesium chloride, and make that from stock solutions. So what this problem is actually describing is this. You have 3 bottles. Each of them has a different component. These are your stock solutions. And what you're going to do is you are going to make one solution that contains a small amount of each of those. So you're going to have a beaker, you're going to make 100 milliliters total, and you're going to take a certain amount of tris, a certain amount of KCl, and a certain amount of magnesium chloride. So the question is, how much? And so the common error that I see here is that students quite often will add up all of these. So they will take 200 millimolar tris, so 200 millimolar, and then they will add the 10 millimolar of KCl, and then they will add that 5 millimolar of magnesium chloride, and they will get an answer like 215 millimolar and plug that in as their final concentration, which is incorrect. Do not do this. So what do we do instead? Well, what you need to do is you need to consider each one of them individually. So you're going to calculate tris first. And you're going to say, okay, C initial, volume initial, and then final concentration and final volume. And so the initial concentration for all of these is going to be 1 molar. The final concentration will be 200 millimolar, and the final volume is 100 milliliters. So you're going to have 1 molar times VI is equal to, and again, remember, convert. So this is the same as 0.2 molar. So 0.2 molar times 100 milliliters. So VI is equal to 0.2 molar times 100 milliliters divided by 1 molar. So again, the moles per liter cancel out, and your VI is equal to, just like last time, 20 milliliters. And then you're going to take your KCl. Potassium chloride calculation. Again, same idea. Your initial concentration is 1 molar. VI is what you are solving for, so we don't know that one. Your final concentration, in this case, is going to be 10 millimolar, which is the same thing as 0.01 molar. So 0.01 molar, and the final volume is still 100 milliliters. That's what you are making in one beaker. So solve for VI, 0.01 molar times 100 milliliters divided by 1 molar. Again, the moles per liter cancel out, and your VI is 1 milliliter. And then you solve separately for magnesium chloride, Cl2. And so here again, your initial concentration, it's a 1 molar stock, so it's 1 molar. Your initial volume, we don't know, so we're going to be solving for that. And that's equal to your final concentration is 5 millimolar, which is the same thing as 0.005 molar. So we plug that in, 0.05 molar, times, again, we're making 100 milliliters of this stuff, so 100 is still your final volume. Solve for VI, so 0.005 molar times 100 milliliters divided by 1 molar. So again, the moles per liter cancel out, so we're going to have milliliters as our final units. So VI is equal to 0.5 milliliters. So let's go back to our sketch. So now we know that our amount of tris that we're going to use is going to be 20 milliliters. The amount of potassium chloride that we're going to be using will be equal to 1 milliliter. And the amount of magnesium chloride we'll be using is 1/2 of a milliliter. So that means that in total you will be adding 21.5 milliliters of stock solutions into this beaker, which means that you will be adding 79.5 milliliters of water. Okay, that will be the rest. So that's the thing that a lot of students will also forget, is that when you calculate how much of the stock solutions you need to add, the remainder is going to be, in most cases, water. Okay, so those are the three main problems that I frequently see when students do their calculations for this. Hopefully this helps you resolve some of the issues that you might be having with these calculations. I hope this has been helpful. We'll see you in the next video. Bye.